In this final exam review video, I just want to go over some examples of using classes and objects in Python, as well as a bit of exceptions too. So in this first example here, let's create a class to represent basketball players, and we'll create a class to represent teams. And basketball players are going to have the attributes of the player's name and points per game, as well as a method for printing a player. And the class to represent teams, we're going to have attributes for the team name and a list of players. And we're initially going to have the list of players be blank or empty. And then we're going to have a method that allows a player to be created based on user input. So we'll ask the user for the player's name and points per game. And because the user could put in bad input, like maybe a string for points per game instead of, like a string of characters like ABC instead of something like 24.5 or something like that, we're going to use a try except block to report errors related to the input data. We'll also create a method to print all the players on a team and a method to print the top player on the team by points per game. So let's first make the player class. So we'll say here class player, and we'll say definition init. And we're going to say that when we make a player, we provide a name and points per game. And we'll set self.name to name and self.points, not points, pointers per game, points per game. We'll say points per game to points per game. And then if I wanted to make a player, I could say something like this. I'd say like X is equal to player, and I'd say like give a player name and give a points per game. And then I have an object X there that has these attributes. So we could say like print X dot name, and we'd get, the player's name. And so, now we've got a simple player object type here already. And remember, when we're making these methods for our object type here that we define with class, you always have to have self as the first attribute, and that's going to be a reference to the object itself. And then we can set up attributes like this by saying self.name, self.whatever is equal to, and set them to whatever we want. We also said we wanted a method to print the player object, or print the player object contents essentially. So we're going to say definition print player self, and we'll just say print, and we'll print out like the name and the points per game. So we'll say print the name, print points per game. Okay, so now I've got a player object there, an object type there. Now I'm going to say class team. Let's make the team object. So we said teams are going to have a name. So we're going to have self and name here. But then we also said that the list of players would be initially blank. So we're going to say self.players is equal to empty list there. And then we wanted a method that was going to allow the user via input. Oh, this should be not class, that should be def. But we also said that we would have a method to allow the user to add players via user input. So we're going to say here definition add player, and it's not really going to take any arguments in but self, because all methods have to have self as that first argument there. And then we'll ask the user for input, and we'll say like name is equal to input, enter player name, and then we'll say points per game is equal to input, and we'll say enter points per game. Now with points per game, I want this to be a floating point number as opposed to a regular string. So I would say float to convert the string that input normally gives us back into a floating point number, because points per game is going to be something like 20.4 or something like that. So we want it to be a float. And then once I've got these two values, I can use these to make my own player object, and I can append that player object right to this list here. So I could say like self.players to refer to this list here. And then I'd say .append to append something to that list. And what I could append is a new player object. So I'd say like player name points per game. And this is going to add in, a new player object to that list there. Now, with this method as it is now, this should work. I should be able to say like, Raptors is equal to team, and we could say Raptors here, and I should be able to say like Raptors.add player and call the method. And I should be able to put in a player and a points per game, and it's all good. The only thing is, if I were to do something like this and maybe put in the input wrong here, so I'll say like 20.4 or something, I get a exception here, a value error, because what was expected here was a float, and it's not going to work. It's giving an error on this line here, value error. So I could put in a try except block here to catch errors like this and handle them in a more sort of graceful way, so that way the program doesn't just crash. So I could say like try, here's the code that I'm going to try, and then accept. And if an exception occurs in here, then it's going to skip down here and run this code rather than just sort of crashing. So I could say like print, and I could say player data entered incorrectly. And now if I try to put in a player that, has some bad data, like I'll say, 20.4 or something, it just says player data entered incorrectly, and we don't have that kind of hard crash because we've done this try except block. And this except here, remember, this is the one that'll catch any type of exception. If I had said something like value error here specifically, it would still work because that error type that we had before was value error. But this will then catch any kind of exception, which might be, better in this case, because maybe there could be some exception that we haven't even thought of that could occur. And either way, we'll catch it this way. So we've made the add player method now. Let's keep going with these methods here now. Let's make a method to print all the players on the team next. So we've got a way to print players, and we want to make a method to print all the players on the team now. So we could say like definition print team, and we'll make a print team method now. So we'll say like print, we'll put in some new lines just to put things on a new line. We'll put the name of the team, and we'll just say like player roster. And then what we could do is we could loop through all the players in this list here and just print out all of them. So we could say like for player in self.players, player.print player. So we're going to call each player's print player method to print them out. And then we'd have a print team method there as well. So then, now we could test that out. So we could say like Raptors dot print team. And if we run this here now, it doesn't like something. So I'm just going to restart and clear everything. It doesn't like this. Oh, kernel restarting, please wait. So I should just wait. Well, while it's doing that, I'm gonna keep typing. So we're printing out we've got a method here for printing out the team now. Let's try to find the top player. So we said that the top player is gonna be the player with the highest points per game. So I could say something like this. I could say definition, and I could say top player. And this is gonna be a lot like the sort of max functions that we've made in the past, where we're basically looking for the max for points per game for a player, and that's going to be our top player. The one case we might want to handle is what if there's no players on the team? So like what if we haven't added a player yet? If that's the case, we could say, well, if the length of players is equal to 0, then print no players added yet. But then other than that kind of case, that special case of there being no players on the team yet, we just want to find the top player. So if we have it that, the number of players on the team is not 0, there's got to be at least one player on the team if that's the case. So what we could say is, let's start off by assuming that the top player on the team is the first player. So we'll say that, let's say that the top player on the team is initially going to be the first player. And then what we'll do is we'll check all the players. And if any player has, a greater points per game than this player, then we'll make them the new top player. And if we keep doing that, that'll give us the maximum points per game player back, the top player. So we'll say for player in self.players, if player points per game, keep saying pointers. We'll say points per game is greater than the top player's points per game. So this is the max kind of method that you've probably seen a couple times, actually, in a couple other examples. So we're going to say here, for each player in the list of players, if the player we're looking at has a greater points per game than the current top player, who we initially just sort of say, oh, it's the first one, and then we'll just see from there. So if this player has greater points per game, then they're the top player. So we're going to say here, top player is equal to this player. And then we would just print out this top player. So we'd say like print, we'd say top player, we'd say top player dot print player, and then that should print them out. So now oh, my kernel's still restarting. Interrupt. We'll restart and clear output again. Restarting kernel. Okay, looks like it's working now. All right, there we go. Enter player name. So we could say, we'll put in a player name here. And we expected that to print out the team. I think that maybe the kernel was still doing something there. There. So there's our output of the player roster there. And maybe I could do something like print out like maybe a line here, because I noticed that it's sort of like Raptors player roster and then just the name right there. I could probably print out like a line here just to make it maybe a little bit more nice. So I'll just say print out a line like that. Okay. So we were adding a player, printing a team. Let's try to add a couple more players, and then we can find the top player too. So we'll say like Raptors.print the team, and we'll say print out the top player. Okay. So now we're going to add 3 players to the team, and then we're going to print out the team. Then we're going to do the top player of the team. So let's enter some players here. Okay, one more. And we get the Raptors player roster with the 3 players. And we get the top player is the one with the highest points per game. Highest points per game. So anyways, that's an example there of, creating a player object type, a team object type. The team object type uses the player object type. We've got some exception handling here. And, we've got some logic in our methods here. So this is one example of using classes and objects. And hopefully this is kind of a nice little review of some concepts. We'll do one more example. This one's kind of a fun one. Let's represent rational numbers with a class. And rational numbers are basically fractions where you have like a numerator and a denominator. And the one thing is you can't have a 0 denominator, right? Because you can't divide by 0. And we're going to create a class to represent rational numbers. And when we go to make a rational number, if someone tries to make a rational number with 0, we're going to want to raise an exception. We'll create a method to print a rational number. And we'll create a method that's going to reduce a rational number to its lowest terms. So if you had something like 2 over 4, it would turn into 1 over 2. And then we'll make one more method that's going to add a rational number to a rational number and return the reduced result. So let's check out this. We're going to say here class rational number, and we're going to say let's make a rational number. So when we make a rational number, it's going to have a numerator and a denominator. And we're going to set the numerator to be the numerator and denominator attribute to be the denominator. And what we're going to do is we're going to check. We're going to say that if somebody tries to make a rational number with a denominator of 0, we're going to raise an exception. So that's kind of like where we create our own exceptions, or our own method has an exception. So we're going to say raise exception. We're going to say cannot have a denominator of 0. So now if I try to make a rational number, like I'll say like half is equal to rational number 1, 2 for like 1 over 2, that's going to work okay. But if I had like this number here like does not exist, I'll say rational number, and I'll say like 1 over 0, it's going to raise that exception that we can't have a denominator of 0. So we're able to make rational numbers now. Let's make it so that we can print them. So we'll just say definition print number self, and we're going to say here print, and we'll say here I want to print it in a nice way, so I'm going to use the string append. But both of these are going to be numbers. Like numerator is going to be a number, so is denominator. And when I want to use append, like if I want to say like ABC append 1, 2, 3, both of the operators of this, or both of the operands of this append here have to be strings. And I want numerator and denominator to be numbers. So if I want to turn a number into a string, I'm going to have to convert it. So I'm going to have to say here like string self.numerator plus, I'll put the slash in, plus string self.denominator. So I'm doing that str there to convert a number into a string. So that way I can use the string append operator to append two strings together. So now I could say like half is equal to rational number 1, 2, and then I could say like half.print number, and I get like 1 over 2 there. So then next, let's make a method that's going to, we'll make the method first that's going to actually add a rational number to another rational number, and then return the result. So we're going to say that we're going to have a method here, add, and the method's going to take in some other rational number. And what it's going to do is it's going to add this rational number to that rational number and return a new rational number as the result. So if we have two rational numbers and we want to add them together, they need to have that common denominator. And so what we're going to do is we're going to say that the denominator is going to be self.denominator times the other rational number's denominator. Now that's not going to be the lowest common denominator, but it'll be a denominator that'll work. And then we're going to say that the numerator of this new number is going to be the self numerator times the other number's denominator plus the other number's numerator times this number's denominator. And this is just the sort of algorithm for adding rational numbers, where if you have like a b and you have like plus cd, then this would be equal to, ad plus bc over bd, right? This would be the sort of way that we produce it. And we've just sort of done that here in code. Now, this is not going to be a pretty number because the denominator is going to be bigger than it needs to be, potentially, but it'll work. It's going to give us the correct result. And we'll worry about reducing it next. But this will give us a numerator and denominator. And then what we'll do is we'll create a resulting rational number with these things, and then we'll return that result. So we say like the result is rational number with this new numerator and new denominator, and we'll return the result. So then now if I have half here and I'm printing the number, I'll say quarter is equal to rational number. We'll say like 1 over 4. We can print out quarter. And then we'll say here result is equal to half add quarter. And then we'll do a print of the result. So when we have half here and 1/4, we'd expect to get 3/4 back, right? That's what we really want to have, is 3/4 back. We get 6 over 8, which is actually pretty close, right? It's the same number, it's just represented differently. So we've actually got a method here now that'll add two rational numbers together. But what we'd really like to do is get a prettier number back. We'd like to be able to get the reduced number back, like 3 over 4 instead. So to do that, we've got to figure out how to reduce our fraction here and just simplify our fraction here. And if you think about how that's going to work in terms of an algorithm, what we're going to want to do is find the greatest common denominator of the two numbers. So, and then divide them both by that greatest common, or not greatest common denominator, greatest common divisor of the two numbers, right? And then we'll divide both numbers by that greatest common divisor. So I'll say here definition reduce to reduce the number. And then we're going to say what's the lowest number, because that's what we're going to have to check up into for the greatest common divisor. So we're going to say, what's the lowest number? Is this one, is the numerator lower or is the denominator lower? And if the numerator is lower, then we're going to say that if the numerator here is higher, that we're going to say that the lowest is the denominator. Else, we're going to say that the lowest is the numerator. And then I'm going to say here the greatest common divisor is going to be 1, we're going to assume. And then we're going to check every number between 1 and the lowest number between the two, between the denominator and the numerator. And we're going to say range from 1 to lowest plus 1, just because remember the way range works. If we said like range 1 to 6, that would be like 1, 2, 3, 4, 5 that would be checked. So we're actually going to say range 1 to lowest plus 1. So that way we go all the way up to the lowest number in terms of what we're going to check. And what we're going to check is, does this number have a remainder of 0 when we use it to divide the numerator and the denominator? So if we take the numerator and we do modulus this number, and that's equal to 0, and the denominator modulus this number is equal to 0, then we have that the number divides both numbers. And we'd say that this number is now the greatest common divisor. And we can just kind of keep updating the greatest common divisor, because we're going to go from 1 to higher and higher numbers. And so whatever the last number is, that should be x there. Whatever the last number is, that is a divisor of both the numerator and denominator, that's going to be the greatest common divisor, because it'll be the last one in an increasing range that we check. And so then once we've got that, we can just sort of take the numerator and we'll divide it by the greatest common divisor. We'll take the denominator and we'll do the same thing. Now, normally if you do divide like this with Python, you'll get a floating point number back. So even if we did like 4 divided by 2, we would get 2.0 back. You can do integer division in Python like this if you put in a double slash. That's a bit of a niche thing, but it's kind of good to know and good to use. So once we've done that though, we can now reduce a rational number to lowest terms. And so what we could do is, before we return the result here, we could say take the result and reduce it. So now when I run this here, we get 3/4 back, and we've reduced it based on the greatest common divisor being 2 in that case. So anyways, this is just another example, just to show you another example of doing classes and objects in Python. So hopefully this was helpful. Thanks.